All right, we're in Aarhus with Anders Hejlsberg and Lars Bak, and we're here to talk about TypeScript and JavaScript and Dart. And let's start right off. I mean, so we announced yesterday TypeScript, so right on. I wanted to quickly get Lars's take on it. So what do you think of TypeScript? You haven't had a lot of time to digest it, but...
That is not true. I actually looked at it yesterday, but I have not coded in it, of course. It seems like a safe bet, right? It's to me, it looks like a coffee script with optional typing, right? You get classes and you have this optional typing, which is great. The optional typing is not that far away from what we have in Dart. There's a little bit of type inferencing going on. Other than that, at the end of the day, it still compiles down to JavaScript. So I don't know what the intent is with it, if it's to influence the standards committee to adapt that kind of stuff. But I know that they have discussed the classes and types as well as part of the ECMAScript 4 proposal. Maybe you can comment on that.
Yeah. Well, let me add. You know, your CoffeeScript analogy you're right that it compiles to JavaScript. I will say though that unlike CoffeeScript and unlike Dart, it also starts with JavaScript. So it's a superset of JavaScript. So you can just copy and paste your code in, and then there are only a few extra concepts you have to learn. That was sort of part of the reasoning about not creating a new language, but just starting
from JavaScript to
TypeScript.
TypeScript, not the other way around.
Well, the compiled output is JavaScript, so it sort of starts and ends with JavaScript.
I mean, and that's something I've seen because online, of course, there's a lot of comments, a lot of good buzz, a lot of questions, and so I mean, TypeScript is JavaScript. It's a JavaScript. Is that one way to think about it?
It's a superset of JavaScript.
Okay,
I mean, to technically correct, right? I mean that's what it is.
Cool.
Now the features that are in there, optional static typing, classes, modules, arrow functions, REST parameters, the latter four are all, aligned as closely as we can with what's currently proposed for ECMAScript 6. So we're not actually trying to sway the committee in one direction or the other. Rather, we're trying to follow where the committee is. We actually had a different design for classes originally, and once the committee decided on the max-min proposal, which is the current one, we went back and realigned. I still like parts of our old design better, but
so I can ask you this question: since it's not determined in the committee which way to go, what if they take a different route?
Well, then we'll
adopt.
Yes, this is. I mean, that is our intent. Now it all depends. I mean, I can't say because I don't know what's going to happen, right?
Okay.
But that's the intent, and that's why we had internal teams using it, and we changed the model of classes and broke everybody, and and so for this reason it's a preview, right? And so it wouldn't make a lot of sense for us to have a different model of classes from what ultimately ends up in ECMAScript 6. I mean, that would just be
So just to make one thing clear from my side, I think it's great that people are innovating in the web space. So thank you for doing yet another language for the web. Just to make sure that we contrast a little bit to Dart, right? Dart is a very different kind of programming language where we from scratch are trying to make cleaner semantics.
Yeah.
I know you have some opinions about the basic semantics of JavaScript, but we actually try to clean that up in Dart. And we're trying to solve other stuff than just having optional static types and a clean semantics, right? We also want to have better performance, and we think actually we can make the runtime go much faster. Well, we already know it's running faster because it's doing that today, but in a short while we'll have a fairly good factor compared to JavaScript. And startup is important to us for big application, and I think that's a problem with JavaScript, even for TypeScript, where you generate JavaScript and use the JavaScript in as startup performance. And the reason why I'm mentioning it as a problem is that JavaScript, in order to set up a JavaScript program, you have to run the script. There's no way around it. There's no sort of declared structure in JavaScript when you set up the program. So that's just some of the differences between the TypeScript and Dart.
Well, I mean, that's actually a great segue because you're not really necessarily solving the exact same problem. I mean, in one sense, I mean, But can we talk about the elephant in the room, which of course is JavaScript? And what I mean by that is, I mean, in some sense, we see a lot of this out in the real world where people are trying to make they're trying to do these contortions to make JavaScript more of a structured language or simpler to use or more familiar to object-oriented developers and stuff. But one of the questions I'd like to ask right off the bat is from an angle of the JavaScript developers who are perfectly content with this very kind of strange world that they're in. And in some sense, this might be a test bed to see whether or not they really want classes and interfaces and that kind of stuff. And in Dart, it's true. So that's my question. Like from the JavaScript developers' perspective, the ones that deal with this, the ones who write jQuery and deal with it every day with the really kind of strange syntax. This is going to see whether or not this actually makes sense in their world. Maybe they don't want structure. Have you ever thought about that? I mean, both of you.
Yes,
sure.
Okay. Of course we have.
Of course.
Yeah. So there's reasoning behind the madness. I think in both cases we're at least trying to have a few common goals with these two languages. One is that I think we all experience when you do big JavaScript applications, they turn into spaghetti code, and they're very hard to maintain. At Google, we often try to put more structure on JavaScript by having guidelines for JavaScript and put in comments that will sort of describe the types that are being passed in for the parameters and so on. This is all an attempt to get structure in JavaScript to make it more maintainable, the code. So that's part of the reasons why we started, at least the Dart project. It was to make sure that we can improve programmer productivity and also allow tooling to help manage the code afterwards. That's one of the big advantages of having types. And I guess, Anders, you can just either agree or disagree.
I think what certainly the design of TypeScript was very much driven by feedback from customers, be they external or internal, using our tools or the tools that they wish we had, to write JavaScript code and go, this is too hard. And, you don't necessarily have to have classes and you don't necessarily have to have modules, but boy, they do help you structure your code. And I think the world sort of has proven that object-oriented programming is useful for at large, and that modular programming does have certain advantages. It doesn't mean that you have to use it, but it's there. I also think, that static typing, the last decade of IDE advancements, with refactorings and code completion and finding references and navigating big code bases, a lot of that is driven by static type information. And if you don't have the static type information, you just really can only go so far before the guesswork starts. And then sometimes you're going to guess wrong, or you're not going to have a guess at all. And so you're not going to be able to provide the help. And that's fine for small code bases or single developer code bases where you can keep everything in your head or see everything on the screen, but as code bases get into the thousands or tens of thousands of lines of code, you need help in reasoning about them, and that's really what this is about. It's very much about doing what we need to do to bring the tooling up to the level of excellence that we want to be at. I would add too, that one of the interesting things about starting with JavaScript is that with TypeScript we allow you to use all of the existing frameworks that are out there, and yes, JavaScript has all sorts of problems as any established adopted technology does. They're never pretty, they're never pristine, because lots of people have worked on them over lots of time and committees and what have you. But on the other hand, what they do have is they have an enormous community of users and an enormous community of code bases out there that you can leverage, right? And we're being very conscious about, not messing with that and allowing people to use jQuery, Node, _Backbone, and actually sort of dip their toes by, gradually providing static type information. We've written the static type information for the DOM, for the JavaScript runtime, for Node, for the beginnings of one for Node and for jQuery. But the good news is that even without them, we can still deliver value, but with them we can deliver more value, and you still don't have to go modify any of these libraries. You can use them as they are.
So I guess one question, I mean, clearly that this is most helpful for large code bases, as you mentioned, but when does it get too large? Like if you think about, you know, I won't say real applications, but canonical applications can be in much larger than Gmail and Hotmail and stuff like that, you know, the big web applications. At some point, doesn't it just get too big in general for the infrastructure? I'm wondering how far
Sure.
can JavaScript scale?
Yeah, I mean, there are limits today. Probably, I don't know where the limits are. I'm continually amazed by the fact that these large applications actually do load and do work and are still, you know, some of them are into hundreds of thousands of lines of code, right? And the strides that we've made, you know, like thanks to your work and the work on Chakra in IE is amazing, you know. So you know, I must say I have been surprised at what you can do.
Yeah, so it's certainly true that V8 sped up and a long time ago the execution of JavaScript. That's good. So browsers are faster today, and this is all good for the users. I think if you contrast these two languages we talked about, right, the TypeScript is still a very safe bet, whereas Dart is actually trying to change some of the fundamental issues that's with JavaScript. And I still, from a computer science background, I still have problems with that. You can design an application with libraries where you can monkey patch the libraries when you get up running. I just find that very, very disturbing when you're trying to write big applications. So even though it's admirable to do a language that translates to JavaScript, but still, if you can write normal JavaScript, it means that you can monkey patch the basic libraries, and you'll end up in the same mess as if you use JavaScript to start out with. I think that if you do the right kind of, if you type check everything, that'll probably be prevented. But it's still a risk when you use the basic execution and then JavaScript. So at least when you mix JavaScript and this new language very tightly. So I think it's about risk, and I'm willing to try the extra bet and go for something new. I think there's I guess you haven't looked at Dart.
Oh no,
Well,
I've looked at it. Yeah,
Okay.
yeah. It's been a while, but
been a
you know,
while.
when it first came out, yeah, I
Good.
took a look.
So, but I think it's the object model is much simpler. It's pretty much inspired by the Smalltalk object model, where objects they have a fixed format when you have created it, and if you want to do a dynamic object, you basically have to create a map or a list and use that.
Right.
And then we put in stuff that I think is important in a language, like instead of only having floating point numbers, which is the basis for computation in JavaScript, we actually have integers. I like integers because you can actually reason about them.
They have their uses.
Oh, you do?
Yeah,
You think that? Yeah. So having a language that's based on numbers or doubles, and you behind the scenes work really hard to make it act like integers, is I think a fundamental problem in my mind. So I really like integers when I code for loops. I don't want them to behave semantically like doubles.
No, I you know, everything you say and more, I will readily agree. But the question is not whether JavaScript is broken, you know, in places. The question is whether it is broken enough to merit being replaced by something else, right? And I don't know the answer to that question, and I don't know who if anyone knows, you know, we'll have to see.
So,
but
yeah. So one thing I thought about, and I also have mentioned before, is that in order to make JavaScript fast, you have to apply a lot of heuristics to the compiler, and it has to do with this, if the shape of the object has a well-known form, then you can optimize, otherwise not. And that means that in certain situations, where if you from the side are manipulating an object that's hot in the JavaScript engine, suddenly the performance degrades. And I know people are trying very hard to make that not happen, but it's still the case for all fast JavaScript engines. And that's something I'm also very keen on is to have a language like Dart where you can predict that the performance will not degrade no matter how you use it from the side. And I think we cannot sell Dart as just on the language part. We also have to make sure that system properties are demonstrating it's better in some respects, like performance and predictability in performance and size, right?
Sure.
So I had my play in V8, and we all do these hidden class or shapes of objects behind the scenes. And depending on how dynamic a program is, right, the bounds of or the limits of these hidden classes is huge, right? So you get bloat in the VM, and there's no way around it, no matter how you do it. So in JavaScript program, where you invoke it on an optimizing JavaScript engine, you have some bloat associated with trying to recognize structure behind the scenes. Stuff like that we can avoid completely when running Dart. So I think there's many issues. You can discuss it if it's just the language, right, if it makes sense to make new language. But I also would like to see it as if you actually build an application in this new language called Dart, then you'd also get some guarantees that it's faster if you have the Dart VM installed in your browser, of course.
Understood. So I mean,
we also translate to JavaScript, by the way.
Yes, you do. This is true. But besides the Dart versus TypeScript, because there's such very different solutions to a similar problem, obviously, but one has to ask that JavaScript, why can't it be like C to C++ in the sense that you have JavaScript. JavaScript is not going to go away. Now, it may go away, but I don't know that it's really ever going to happen. It seems to just continually grow in terms of use. Even in Windows now, in Windows 8, you can build native HTML5 applications. You're programming in JavaScript or TypeScript, and
why does it have to go away? I don't.
But this is what I'm trying to. This is where I'm trying to get to. You mentioned these fundamental problems. If the language evolves to a level where those problems disappear, then there won't be a need to invent a new language with a new virtual machine. You can just have JavaScript, the modern version. So JavaScript++, which has classes and interfaces and object orientation, fixed problems.
You see,
Is that not a reasonable?
Oh, it is a reasonable if you have infinite amount of time. So I'm getting close to pension age, and all respect for the committee doing JavaScript. But if you have seen the adoption of new standards in JavaScript, I don't have time.
Okay.
So it's we started with V8 in 2006. And the big hot thing there was to do ECMAScript 4, which for reasons I do not really understand, folded completely. I guess you can elaborate on that.
Actually, I was not involved in ECMAScript 4 either, but so, yeah.
No, but as a representative for the company.
Oh, I see. Yeah.
Anyways, the point is that it's pretty much the same language as we started with in 2006, right? There's been a few additions. There's ECMAScript 5, but in reality, most programs out there are still ECMAScript 2.6.2 revision 3. So it doesn't change that fast. So when you say, well, why not make it incrementally better? I hope it can happen that way, but right now it doesn't seem to go very fast. It might be they'll change after airing this, but I think the innovation, right, in the web space is crucial, right? I think what the big problem is right now is that if you don't innovate with new languages, new systems in the browsers, the proprietary mobile platforms are taking over, and I don't like that. Right? So we need to make sure that we push this technology as far as we can to make sure that web technology is also brilliant when it comes to mobile phones. And we're doing our part, like both of us, I guess, in doing better languages and systems for the web.
Interesting.
Yeah. Yeah, it's a bit of a conundrum, because the real power of JavaScript is the fact that it runs in so many different places, on so many different devices, and on so many different platforms, built by so many different people with so many different agendas, right?
Yes.
And it's really hard to get them all to agree on stuff, right? But there are some things that have been agreed on, you know, like an ECMAScript 5 did move the ball forward, and it is getting to a point where most of the browsers now support strict mode and you know, a bunch of the stuff that's in ECMAScript 5. And you could certainly envision like stricter mode, you know, with like, even with hints for object layouts or whatever. I mean, there are certainly things that could be done, you know, to JavaScript to make it run faster as it exists, right? Or, you know, I don't know,
sort of,
you know.
That's a great point, guys. That's sort of what I was trying to get to you in terms of, you mentioned that, I mean, you're saying that V8 and the work that you guys do, the great work that's been done and the great work that we do in Chakra and stuff, which are use some of different techniques, and I'd love to have that conversation in a different interview here. The question I have is, as you mentioned, you could make JavaScript execute faster if you changed the language. If you added constructs to the language, as you were just saying. I mean, if you
Yeah, I think I was trying to say something subtler. I think you could make it run faster if you provided hints about how it might run faster. You might, for example, have a hinting system that, you know, just like a string literal that says nothing, you know, like use strict, and if you or whatever, you know, you could have some information in there that everyone would ignore except for those who look at it, you know, and understand it. Do you know what I'm saying? And pick up the hints that are in there. For example, I mean, I'm not, you know, I'm just throwing out ideas here, you know, and
like,
so
it's like pragmas in C. They're great, yeah.
Well, I you know, I'm not. It's not. It's.
Right on. Well, I mean, the performance, we can geek out on the performance stuff soon. We'll bring over Steve Luco. We'll dig into what they've done with Chakra, and because it's really, they're both really excellent solutions to a very hard problem. And the questions will become, are we sure we can't get any faster? But continuing on.
Of course, we can make it faster. We can always make stuff faster. It's just a matter of throwing resources at it. So I don't think that's a sure answer on that one.
But if you can make if you can make JavaScript faster, let's say you have infinite number of resources, right? People always say that about Microsoft, right?
Sure.
Just throw another 1,000 developers on it. You guys have all billions of dollars in the bank. But you know, in reality, you know, in some sense, if you can get faster. And the language doesn't have to get better. To me, seems like that's a waste of time, is what you're really saying. I mean, why doesn't the language just grow up to meet its needs, right? Everyone's writing these giant applications in JavaScript, a language that wasn't designed for that. I mean, it wasn't.
No.
Brandon's the first person to tell you.
Yes.
I had no idea what ever turn into this. This is
Yeah.
crazy.
Yeah.
So it has.
Yeah.
And now you have to deal with it. One way to deal with it is to develop a beautiful alternative, you know, a brand new language with really modern or some old things. Of course, you do some small. You have that really interesting isolate model. I mean, it's interesting. It's a very interesting model. That's one way, but it's completely new.
Yeah.
You have these thousands and thousands of developers that are already writing in a very different context. So it's going to be like bringing people to D from C++. It's going to take time, even though D is a beautiful language. But we'll see if that actually happens. The code base for C++ is just insurmountably large. Now, in this case, this is why I'm asking, you have these two very different approaches. At the end of the day, the goal is to make developers more productive, right? And in big projects, and that's what you mentioned from the onset.
That's one of the goals.
That's one of the goals. Because you know, on the TypeScript side, it doesn't actually change the semantics of the actual language, or it doesn't make it safer or more robust.
Right. TypeScript is purely a tooling thing,
Yes.
you know, and it all goes away at runtime, right? Where Dart is, well, Lars described it, but there's a VM there.
Yes.
And it's a different design point, right?
Absolutely.
So, yeah.
Well, we also preserve the same semantics of Dart when you translate to JavaScript, but it's more strict in terms of that.
It's certainly closer than Java or C#, and yeah, you know, if like GWT and ScriptSharp, for example, yeah, you know. So.
But I think one thing it's still important to talk about the optional typing, at least for Dart. I haven't looked I haven't tried the TypeScript that much. But in Dart, right, one of the design points for the optional typing was to make sure that when you do experimentation inside the browser, you could do that without being bothered by types, which is great, because then you can, in the debug, you can just evaluate expressions as if it was untyped.
Yeah.
And as you develop the application in a prototype stage, we can just ignore the types. And as you get more structure on your program and your interfaces, you sprinkle in the types where it makes the code more readable and makes it sort of usable by other teams. So that's also one of the reasons why the optional static types are put in Dart. And I think if you contrast these web programming languages to more traditional programming languages like C# and Java, they completely miss the boat when it comes to incremental execution. And I think we just need to face that this is an important part of web development, that you get instant gratification when you do web apps.
Yeah, no, it is interesting both with Dart and with TypeScript that there's this space in between statically typed and dynamically typed, where these languages allow you to dial it to where you want to be. If you don't put any type annotations, then you're just running in the dynamic world, and then certainly in TypeScript, it's basically JavaScript at that point. But if you start adding type annotations, then we will statically check those and make inferences based on those, such that we can infer further types and carry those forward. And thereby, the tooling lights up, and we get you code completion and whatever. We get you error checking, red squigglies, blah, blah, blah.
One of the difference, I believe, is that in Dart, objects carry runtime type information, so you can actually do verification of the types as you run. If you use a special flag, you'll basically check that the assignments obey the types at runtime. So if you have a piece of code that's mixed mode, like part of the code is untyped and part of the code is typed, we make sure that when you pass objects from the untyped code into the typed part, at runtime it will actually obey the types. Okay. I think that that gets harder when it's only a tool, unless you generate special code.
Sure. Now, and we have considered having a debug mode where we inject more checks based on the static type annotations, which currently is not there. And that will add cost, no doubt about it. I mean, like trying to verify that a function object actually has these 3 parameters that you think it has is non-trivial. Checking that something implements an interface, means you got to go grovel through all the properties and see that the right ones are there. And then if they're functions, you need to see, And
that's cheaper in Dart.
Absolutely, I have no doubt it's cheaper in Dart. Yeah, because it sure ain't cheap in JavaScript.
But basically, you cannot do it, right? Because
you can never do all of it. No, but the question is whether it matters enough. I mean that's idea. I mean, because everything has me. It's not. See, the difference here is like in an. Let's say you took away types in a language like C, for example. You took away function prototypes, go back to before ANSI, right? Okay. If you called a function with the wrong arguments, your stack would get out of alignment and your machine would go haywire and start executing the characters on the screen or whatever. Weird stuff would happen, right? That doesn't happen in the JavaScript world. There's a well-defined behavior for everything. There's a well-defined behavior for calling a function with too few arguments or with too many. Now you may not like what the well-defined behavior is, but it's not going to go do bad things in the same sense.
We agree. It's a safe execution environment, is what you're saying, which I understand. I think one point is here that let's assume you have 2 teams. One team is doing a library where they sprinkle types, static types on the interface, and you have another team trying to use that library. The fact that you can validate the types when you cross into that library means that you don't have to debug the other person's code if it's correct, right? You can see it at the interface level if it breaks down. So certainly it has value that you do that. I understand the safe execution environment, but it'll basically amount to that deep down in the other library that's typed, you get an error. Or, by the way, in JavaScript, I didn't know if people are following that. Often you don't get errors. So if you have a spelling error, right? You try to access a field or
get
property that's
undefined.
not there,
Yeah,
right?
yeah.
It just keeps on trucking.
Yes.
And this is
JavaScript thing, yeah.
well. So I'm just saying that,
Keep calm and carry on.
which is fine. I don't have that was the intent of the design, I assume. But again,
knows?
if you run untyped in JavaScript, right, you have these peculiarities that are, as a developer, hard to cope with because you don't. If you don't check there's a spelling error, right, the program will never execute the if statement trying to check that property. Like a common one is like the ready state for an event handler. If you have that all lowercase, right, it just plows through and nothing happens. In Dart, what we try to do as part of the foundation of Dart is that if you try to access a property or invoke a function, or a function is probably wrong, but access a property and it's not in the object, you will get an exception at that point, so that you, during development, can actually see something is wrong. And that will certainly catch it earlier than if you just keep on trucking.
Yeah. I think, it all comes down to static typing is a dial, and you can put the dial in different places and there's different cost associated, both for paying for the programmer and cost at runtime and so forth with the different settings. And there's a certain threshold beyond which it will not make sense anymore for JavaScript because it just gets too expensive, to try to verify. But I do think that I will say I think with TypeScript we're capturing a good 80-90% of the meaningful settings on that dial. So I do think there's a lot of value there, but it's not going to solve every problem known to mankind in JavaScript.
TypeScript would solve the two-team problem in the sense that if you had one team building libraries with interfaces and classes, and then you have another team that has to implement the interfaces, you do that in TypeScript and hand over a TypeScript file that you then would program.
Well, I think what it
right?
the thing that I think has been lacking for large JavaScript development is an agreed upon way to reason about libraries. How do I know what's in this library? And how do I know what's in this other library? And how can I, in the same language, reason about this versus that? And are they compatible? Are they not? How do I document them? And today it's very ad hoc, right? If I'm using jQuery, I got to go to their website and sort of grovel through one kind of documentation. Then if I'm mixing it with Node, then there's some other kind of documentation that uses a different vernacular and plus there's really nothing there that programmers forget to document a few things, or there's this undefined behavior, or it's very ad hoc, right? And I think the thing that's useful about having the ability to write down these static type definitions and annotate them with documentation is that it gives you a place to say what it is and have something validate that what you made actually is what you said it is. It allows you to sleep better at night and have greater confidence that your app will work. When you actually deploy it. So.
And the interesting story there is what you say it is isn't really actually what it is when you define is at runtime, which I think is beautiful. But it solves the core problem of being able to at design time understand what it is.
Yes.
Whereas at runtime, it's still just JavaScript.
Right.
And I think that's one of the really cool.
Well, I think what we've tried to do, not what we've tried, what we have done in TypeScript is basically formalize a static type system that mirrors the dynamic type system of JavaScript, and we have really worked very hard to stay true to that. That it really is JavaScript's type system, and there are no new concepts per se.
Absolutely. Well, it'll get through my head after a while. This is the third time we've communicated, but I think a lot of people are still going to have that sort of cognitive disconnect between the fact that it is just JavaScript, and you've added this type system on top of it, a thin one.
Well, it is when it runs, yeah.
Exactly, but at the end, that's what really matters at runtime.
Yeah.
That's what so rock and roll. I mean,
but we also generate JavaScript and run pure JavaScript, so Dart can be translated too. So
but let me ask
the
you
only
a question
difference,
about
so the big difference is, I would say, about that, it's certainly much easier in TypeScript because of the tight integration with JavaScript to to interoperate with other libraries.
Yeah.
I'm fully aware of that. But as we also heard during this conference, that some websites, they download a boatload of functions when they start up, and they only run a few percent of the functions, right? Which is a pain for download time and so on. So one thing I want to just talk about with Dart is also that because it's more structured, right? Also compared to TypeScript, we can actually do analysis on the complete program and do tree shaking and throw out methods we can prove that are not being executed, so that the deployment of either the generated JavaScript code or the snapshot we have on the VM will be minimal, right? That's much harder to do in JavaScript, because when you glue it in with existing JavaScript libraries, you cannot do that analysis, because you do keyed access on an object, and it's basically the key you use can be a composed string and what have you. So it's very hard to do that analysis because of the lack of structure in JavaScript, regardless whether you put TypeScript on top.
Now, I'm curious actually about the tree shaking. But that only works if everything is statically typed then, right? I mean, if you have anything that's dynamically typed, then how do you know whether you're going to be calling a particular method or not?
Well, for instance, if you know that the identifier foo is not being used.
Anywhere.
Anywhere.
I see, yes.
And that's certainly the simplest form of tree shaking.
Right.
And it works amazingly well,
yeah.
right? So but what you do is you certainly do type inferencing while you do tree shaking, where you start with either the main method or the way you hook it up to the DOM, and then you just plow through.
I know
and
tree
do that.
shaking. Yeah.
And it actually works. It reduces a lot of the code being deployed, and that's what big companies want when they deploy a web app. They don't want all the stuff that's not being executed, of course. So that's a way of doing that. And we actually do the same on top of JavaScript at Google. By specifying sort of pseudotypes and comments, so we can figure out how stuff is connected. But that's only if you use JavaScript in a certain way. So all the code has to be written in a clean way, so you know exactly how the interdependencies of the program are. Yeah.
Interesting. And could you do something like that in TypeScript? I mean, since you have that.
We could do lots of different things if we, absolutely. I don't see why I don't think there's any fundamental difference there. We have not built a tree shaker, and certainly tree shaking, there are certain things we would not be able to tree shake, right? We'd be able to tree shake TypeScript code. We probably wouldn't be able to tree shake JavaScript code. So something like jQuery or whatever, it's not clear that one could tree shake that. But I will say that the thing that we find that people do with TypeScript is that they use it at development time to provide a better development experience, and then they get the static verification, all of the code completion, et cetera, et cetera. Then they compile to JavaScript, and then they use other JavaScript tools like minifiers, packagers, et cetera. If you're using require.js, there are tools to package AMD modules together, and so it just is part of a tool chain, right?
Understood.
And in that tool chain, there are certain tools that will try to shake your JavaScript code too, and some can do some things and others can do other things. So I think at the end of the day, I don't think neither Dart nor TypeScript will ever do everything that anyone will want in that tool chain, right? So you're
general
just
statement, but of course not.
Yeah.
But what I sort of want to get back to that. If you take a library that's written for JavaScript and mix that with TypeScript, I'll just claim that tree shaking is very, very hard, because you cannot compute what's being called. You can try, but it turns out if you deploy something and suddenly you're taking out too much, right, you're in trouble, because then you don't preserve the semantics. That's one of the benefits by having a more structured language for the whole thing. Then you can do tree shaking, and I'll still guarantee that we can do a small competition who can do better tree shaking. But I can guarantee you, I
wouldn't be surprised.
A better hand on that one.
Yeah. For sure, but of course you have a completely distinct language
Yes.
and your own virtual machine.
On purpose, so it's not by accident we have that.
No, I understand, but I think that this is an interesting topic because it's, there really isn't a this or that here.
Right.
It's not Dart or TypeScript. TypeScript is as Andrew was saying, it's a small shell on top of an already existing tool chain called JavaScript and everything that comes along with that. Whereas yours is more of a, let's rethink how we do this from the ground up. So it's a very different thing. The core problem is that everybody has to face is JavaScript is what people use. And when you use JavaScript, you're guaranteed it can run everywhere without having to install a virtual machine.
Yes.
So, but that takes...
But that's the Stockholm Syndrome, right? If you always look backwards, you don't innovate. So in my mind, the argument about, we don't... So when we did V8, right, it was like, why do we need fast performance? All the programs are running fine. I said, that's stupidity, right? So it all boils down to that if you don't innovate, try something new, right? The application developers cannot innovate. And this is what we're trying, right?
Understood.
Yeah.
And nobody's saying that what you're trying is not a good idea. That's what I'm trying to get at.
Yeah.
The TypeScript is not something versus Dart at all. They're very different things.
I'm very happy about TypeScript. I think anything that tries to innovate in the web space is great. Cool. And it's not something that if you do Dart, we cannot do the other. I think there's room for several solutions, and there's already now. It's not like this is the only two new languages for the web, right? There's tons of them already.
Like there's a new one every day.
Translated to JavaScript. So the more the merrier, because at the end of the day, it'll be the programmers out there that will make the decision what kind of language they can use.
Yeah.
And if you look back 20 years, it was exactly the same. Yep. There'll be a lot of languages to choose from, and please do not shoehorn developers into only using one language.
Yes, and that's not, I think, what anyone does. And languages are tools. They're tools in a toolbox. The web is the runtime. So people need to figure out how to take best advantage of what's really happening around us, and both of you are doing fantastic work.
So I just want to say that, right? So like TypeScript, Dart is completely open. Yes, we have a virtual machine, and we can transfer JavaScript. Right. One of the reasons why we open sourced it, also the virtual machine, is of course that when we show this nice property of a running Dart program, we want everybody to take it if they like it, right? So we are certainly not trying to come up with a proprietary technology here. We're trying to sort of free the web, basically.
Understood. And just to do the counterbalance, TypeScript is also open source and runs everywhere, and it's not about only using it in Visual Studio. In fact, yesterday they shipped 3. You can run it in VI, you can run it in Emacs, you can run it in Web. I can't remember the name of the other one, but they went out with just more than just Visual Studio and running on Windows. So I think everybody is into that same mindset, and it's cool to see these innovative solutions. Very different though they are.
No, I'm certainly excited about the open source stuff. I was just like right before we sat down, I was looking. There were like 9 forks created out of the TypeScript depot already. So I can't wait to see what ensues.
Cool, and I can't wait to have this conversation again, maybe next year, and to see where we are in this web world.
That'd be great.
We hope we are both in the business in a year.
Oh, totally will be. Great work, you guys. Thanks for
all right.
Thank you.
Thanks, Josh.
Forward.
Yeah,
it's important.
it's great.
Cheers.